Hi friends, today I want to talk about absolute value equations. In order to do that, we first need to identify what's an absolute value. So if I have an absolute value, the notation for that is going to be two vertical bars on the outside of something. So if I have absolute value of -4, I would write it with the two vertical bars on the outside of -4. Kind of like parentheses or brackets. It's just a separate grouping symbol that has a special property in that the absolute value makes everything in it positive. It returns a positive value. So the absolute value of -4 would be 4. The absolute value of 4 would also be 4. We can think of absolute value as being the distance away from 0. I'm not going to get too much into absolute value, but I wanted to review what it does so that when we talk about it, it makes sense. Now, unlike other grouping symbols, absolute value has to be taken off in a very specific way, separate than say parentheses or brackets or braces might. So when we have an absolute value equation, it might look something like this. 2 times the absolute value of x minus 3 plus 1 is equal to 5. Now, when I write those absolute value bars, I exaggerate them because I don't want them to look like ones. It can be very confusing. And I would encourage you on your own paper to do the same so that it's easy to read. All right, so let's write out some steps. The first thing I want to do is I want to isolate that absolute value. I want to get it all the way by itself. So the first thing I'm going to do on my example is I will subtract 1 from both sides, and I'm going to rewrite this as 2 times absolute value of x minus 3 is equal to 4. So I have subtracted 1 on both sides, and I'm one step closer to having that absolute value by itself. All right? It's really close to by itself, but it's multiplied by 2. So to undo that, we're going to divide by 2 on both sides, and I get absolute value of x minus 3 is equal to 2. All right, so we have isolated that absolute value. The next thing we want to do, every absolute value situation must be broken into 2 cases to solve. The way we do that, the way we break into 2 cases, we're going to replace the absolute value symbol with positive and negative parentheses. Let me show you what I mean. Instead of writing this with an absolute value of x minus 3 equals 2, I'm going to rewrite it as plus and minus parentheses x minus 3 is equal to 2. Now that looks a little weird. We're going to write it as 2 cases. The first one is the positive case, x minus 3 equal 2. And the other one is the negative case, negative of x minus 3 is equal to 2. And I could, on that positive case, leave the parentheses on with a plus out front. I wouldn't have to, but I could if I wanted to. All right, so I have x minus 3 equals 2, and I'm going to multiply both sides by -1 to get x minus 3 is equal to -2. I'm solving both cases. We'll make a little note, kind of running out of room here. So solve both. So instead of x minus 3 equals 2, I'll add 3 to both sides, and I've got x equals 5. Instead of x minus 3 equals negative 2, I'll add 3 to both sides, and I get x is equal to 1. So I have two solutions, x equals 5 and x equals 1. All right, so every absolute value equation, we're going to isolate the absolute value, break into two cases where we replace the absolute value with positive and negative parentheses, and solve both. Let's look at a couple more examples. All right, my first example is a fairly straightforward one. It is absolute value of x is equal to 2. All right, so our first step, isolate the absolute value, already done. Now we're going to break it into two cases. We'll replace the absolute value with positive and negative parentheses. So positive and negative parentheses around x is equal to 2. All right, that's two cases. X is equal to 2, or negative x is equal to 2. And negative x equal 2, we really rewrite that as x equals negative 2. So my answers would be x equal 2 or x equals negative 2. And we probably could tell that by looking at it at the very beginning, but it's good to use our steps to work it out. All right, next example, x minus 3 in absolute value is equal to 1. All right, the absolute value is isolated. It's all by itself on one side. We're going to rewrite this as positive and negative parentheses x minus 3 is equal to 1. We'll break it into the two cases. X minus 3 is equal to 1, and negative of x minus 3 is equal to 1. I'm going to rewrite that second one as x minus 3 is equal to negative 1, and we'll solve them both. So I'll add 3 to both sides. I get x equals 4, and x equals 2. So there's my two answers. I'm going to write an or between them because either one is a valid answer, x equals 4 or x equals 2. And we can take those answers back into the original problem and check them. Absolute value of 4 minus 3, well, 4 minus 3 is 1. Absolute value of 1 is just 1, so that one checks out. 2 minus 3 is negative 1, but the absolute value of that is positive 1. So x equals 2 also checks out in our original problem. All right, next example, 2 times the absolute value of 1/2 x minus 5 is equal to 4. Now, I've put something really tempting here. I've got a 2 and a 1/2 so close to one another, and it is really tempting to cancel those. But we want to remember that that absolute value, man, that is a vacuum-packed, sealed container. And we can't break into it unless we use our method to break into two cases. That's the only way we can break into it. So, even though this is super tempting, don't be tempted. Don't cancel. All right, so first thing, we're going to isolate that absolute value. It's not by itself because it's multiplied by 2, so we'll divide both sides by 2. And I get absolute value of 1/2 x minus 5 is equal to 2. Now we're going to break it into two cases, so I'll write it as plus and minus parentheses, 1/2 x minus 5, close parentheses, is equal to 2. The positive one, 1/2 x minus 5 equals 2. And then the negative one would be negative of 1/2 x minus 5 equals 2, which could also be written as 1/2 x minus 5 equals negative 2. All right, let's solve each of these. So I'm going to add 5 to both sides on that first one. So 2 plus 5 is 7. And I get 1/2 x is equal to 7. Multiplying both sides by 2, x is equal to 14. Now let's work on that other equation. Again, I'm going to add 5 to both sides. So -2 plus 5 is going to be 3. 1/2 x is equal to 3. Multiplying 3 by 2, I get x equals 6. So I have two answers, x equals 14 or x equals 6. All right. I threw another fraction one at you. So the next one, I have absolute value of a fraction. It's 2x minus 3 divided by 5. And then outside that absolute value, plus 1 is equal to 5. Now our first step is still the same. We need to isolate that absolute value. So I'll subtract 1 from both sides. And I get absolute value of 2x minus 3 over 5 is equal to 4. Now we're going to break into two cases. So we'll replace that absolute value with positive and negative of parentheses. So positive and negative parentheses, 2x minus 3 divided by 5 is equal to 4. I'll write that in its two cases. 2x minus 3 over 5 equals 4. And 2x minus 3 over 5 equals -4. I skipped a little step there, but I bet you're okay knowing that this negative always gets moved over to the other side. All right, let's solve. I'm first going to work on the 2x minus 3 over 5 equals 4. We'll multiply both sides by 5. So 2x minus 3 equals 20. Add 3 to both sides, 2x equals 23, and x equals 23 over 2. All right, we're halfway there. On the other one, 2x minus 3 divided by 5 equals -4. Again, we'll multiply both sides by 5. So 2x minus 3 is -20. I'll add 3 to both sides. So 2x equals -17. And I'll divide by 2. X equals -17 over 2. So we get two answers. X equals 23 over 2 or x equals -17 over 2. Kind of ugly, but that's okay. That's the way it goes sometimes. All right. I have two last examples, and I just want to mark these as a little bit of weird cases. Definitely things to be looking for as you're solving absolute values. The first one, I have absolute value of x minus 4 equals 0. Now, it might not look like this to begin with, but if we get the absolute value equal to 0, we are in a weird case. I can't do positive and negative of 0. So the only case that we have is that x minus 4 is equal to 0. And so therefore x is equal to 4. Okay, so just be on the lookout for that. If you were to break it into two cases, if you didn't notice it was a 0 and kind of weird, you would have x minus 4 equals 0 or negative of x minus 4 is equal to 0. And both of them would end up giving you x equal 4 for an answer. All right, so be on the lookout for that. The other one, I have an absolute value of x plus 1 is equal to -2. Now, I want this -2, the absolute value equal to -2, to set off all kinds of alarm bells in your head. Absolute value, remember, always returns a positive number or 0, but it is never negative. So to have an absolute value equal to a negative number, that just can't happen. All right, so no way, nope. Now, the mathematical way we say nope is does not exist, or DNE for short. So be looking for this. Absolute value equal to a negative number, can't happen, does not exist. In the next video, we're going to look at absolute value inequalities, which takes a lot of the same ideas, but expands on it, and your answers will be in interval notation. So look out for that one.